Good afternoon, ladies and gentlemen. Welcome to our presentation of the Photodynamic Disinfection Certified Technology. It's a very unknown issue, the photodynamic disinfection. It's very, very new. We are on the market since last year in January with this technology, especially for the pharmaceutical area. The photodynamic disinfection is very well known in the medical industry. Photodynamic is a reaction of a color with a light, and this reaction creates a singulate oxygen, and this singulate oxygen reacts with most of bacteria and germs. So what we did is, that's a Mother Nature thing. So it's very, very well known in Mother Nature and in the medical area. And what we did as a equipment and machine industry, we took this technology and made it possible for clean room or clean areas. So we had an R&D focus for the last 10 years on this technology, and our partner, and I hope it works now. Oh, no. Yeah. Our partners here were Dustex for clean room clothes, Ortner for the equipment part, and M. Doman for the color. And this technology is, because we need 10 years for that, and this technology is very, very well known, tested in many different testing companies worldwide. One of them is the Fraunhofer in Germany. So, but first of all, we want to find a solution for two reasons. The first reason was on the food industry here. The food industry, up to 18% of all foods are detected with harmful germs and cross-contamination. So 1 of 6 citizens every year becomes a bad foodborne disease. And the EU, as well as the CDC in USA, said that we have to take care a little bit more about our cleanness of the food. That's the first idea. And the second, on the second side, it's a medical side. 4.1 million patients every year are contracted with a nosocomial infection, and about 37,000 patients dies because of this nosocomial infection. And about 20 to 30% of all these infections can be avoided if we are taking a little bit more care of our health. So our vision was to develop a system which works with another Mother Nature principle, so which works not against Mother Nature, which controls only bacteria and viruses, and also pathogenic germs. So we are searching for germs which can control the bad germs, and the good germs can live in their normal surrounding. Our project goals was a few things. The first one was to demonstrate a germ reduction on the garment, on a person, because the dirtiest part in every pharmaceutical process is the person itself. Achieving a disinfection without dead spots, validating the whole process would be a really big goal of our things. Achieving a disinfection effect on all areas, also on shoes, hands, bodies. Using a very short and safe lock procession, keeping the lock procession very transparent, that persons wants to go into this lock, and to find a Mother Nature friendly solution. Our partners, as I told you before, was Ortner, Dustex, and M. Doman. And the whole result is the Photodynamic Disinfection Certified Technology. And certified means that we have very well tested technology. So how does the light-induced photodynamic disinfection works? Photodynamic, as I told you before, is a reaction of a light with light-absorbing molecules. Therefore, we have to use a special dye. And this dye works with a light in combination of a light wave. The light wave is nearly daylight, so around 630 nanometers, so it's nearly daylight. And every time the light goes on this color, on this dye, the dye absorbs a single-add oxygen, and this single-add oxygen is reacting with bacteria and microorganisms. The best thing for that is that it has no effect for human skin, for example. So you can use it on your daily clothes and you will not have any effect on human skin. Okay. Okay. So this is how it works in the for the technical principles. We have a special dye, we have water, we are coloring the fabric of each garment with this special dye, and the dye only works on surfaces. So at the moment we have the dye especially for clothes and for example, to spray it on walls or tables. But the best effect, what we have found out at the moment, is it works best for garments. The garment is a blue color at the moment. And on the garment, if there is the right light wave on, you have a photosensitizer, and this photosensitizer creates the single-add oxygen. Single-add oxygen is the same single-add oxygen how it works with H2O2 decontamination. So maybe one of you will know the H2O2 decontamination. H2O2 is very well known for the pharmaceutical area for decontaminating of rooms or machines. So this single-add oxygen, what we are creating here with the photodynamic disinfection, is the same single-add oxygen as it will be used in the H2O2 process. Photodynamic is only working if there is the light on. So in any time the light is not on the surface, the molecule goes back and it's not working, it has not a disinfection function. Photodynamic disinfection certified means the fabric is tested together with the TTEV guides in Germany. The fabric, the reaction for the human is tested and verified by the Hohensteiner Institute, also in Germany. There is a log technology we have proved at the first time to have a very fast log reduction within 3 or 4 minutes. That's also certified from Fraunhofer Institute in Germany. The whole microbiological testings and verification will be done with the University in Graz, the Research Center of Pharmaceutical Engineering in Austria, and also the Fraunhofer IPA. And the whole system and the light system together was also tested by the Johanneum Research in Austria. Which brings us to the result. The result is a tested device of Fraunhofer, and what we found out with a normal light wave, we have a 90% germ reduction within 3.7 minutes and a 99 germ reduction within 6 minutes. So you will get a log6 reduction in about 8 minutes. So which means you cannot put a person into a log and say, okay, please stand still for the next 10 minutes. This will not really work. But you can have a permanently reduction on germs on your garments during the whole working area. So if you put lights, for example, on the direct workspace, the garment is always working. It's always active. The opportunities are very multiple. As I told you before, we have 3 options at the moment. The first option is in the medical area, medical hospital devices. The second option is in the pharmaceutical area, and the third option is in the food industry. In the food industry, the whole technology we are using for the last 4 years now, and we are verifying the whole technology for the last 4 years, and the results are really super. They are great. In the last picture here, you see we have used it for bakeries, and in this bakery they had a really big issue that they had germs and they cannot destroy the germs directly on the cake. So what we did, we put our garment as like a filter system, a very easy filter system on the top of the whole process, and we got a log6 reduction directly on the germs, which means they have an ISO class 5 during the whole tunnel. And this is a very, very cheap way to install a clean room or a clean surrounding. The second picture here is the garment, how it looks like, the color. And on the first picture you see our airlock, which is also included with a special light system to get the light very quick on the garment. Yeah, these are the areas we are working with: laboratories, healthcare sectors, and the pharmaceutical one. For the healthcare sector, it's very well known, so they know how the effect is, because they have used this times before for detecting of cancers, for example. So they know the technology very well. So for them, it's not the big issue. In the pharmaceutical area, it's very unknown, I would say. That's a very short introduction in our new technology, photodynamic disinfection. So you're very welcome to ask if you have questions. I'm here. We have our booth is in 2M10. I have brought some clothes or some kinds of clothes with us. So anyway, if you have questions, please feel free to contact me or my colleague there.